Fine. So having seen the structure activity relationships of morphine and morphine analogs, okay, these are various classes of structural modifications by different group of scientists at different time intervals. And roughly, we got to know that there were around four derivatives apart from morphine, which also have analgesic activities, right? For example, benzomorphan, benzomorphanon, okay, then meperidine series, and what else we have? Methadone series. And we saw the modifications, what changes they will cause, and which one will retain the activity, and which one will produce toxicity, and which modification would produce a more potent compound than that of morph. Okay. Having seen all these things as part of structure activity relationships, let us see the chemistry of narcotic analysis. Fine. So, as you know, the classification of narcotic analgesics is here. The first category is morphine and its analogs. The examples are morphine, sulfate, and codeine. Okay. And the second category is 4-phenyl piperidine analogs. Examples include meperidine hydrochloride, aniline hydrochloride, diphenoxalate hydrochloride, loperamide hydrochloride, and the pentanyl citrate. Then phenylpropylamine analogs, methadone hydrochloride, propaxipine hydrochloride. Morphon analogs include pentazocine. Morphinon analogs include levorphenol tartrate. And the narcotic antagonists classification, we have three. Three are categorized as one as pure antagonist, that is naloxone hydrochloride, and a partial agonist of nalorphine type. So nalorphine hydrochloride is one, the other one is levorphenol tartrate. And this is the structure of morphine, which is a pentacyclic ring system with one phenyl ring, one hexenyl ring, and ether bridge between those two. And you have one more cyclohexene above. Three rings are fused, and the fifth ring is connecting carbon 13 and carbon 9. And you have one heteroatom in that ring, that is nitrogen, which is tertiary nitrogen. The source of morphine and its alkaloids are the juice of unripe seed capsule of poppy plant, which is having a scientific name, that is Papaver somnifera. And these are the different structural parts. One is tertiary nitrogen atom, the other one is alicyclic unsaturated link, that is the double bond between seventh and eighth position. And you have alcoholic hydroxyl group at C6 carbon 6. You have phenolic hydroxyl group at third position. Okay, you have a ether bridge. So we saw their modifications, and these are the few coexisting alkaloids along with morphine, morphine codeine, noscapine, papaverine. And the alkaloids of narcotic type are into two major types. One is phenanthrene type, example is morphine. Benzyl isoquinoline type is the second one. The example for this category is papaverine, which is having antispasmodic activity. So morphine is a potent analgesic, but it also suffers from the drawbacks like respiratory depression, addiction, and sedation. That is the reason we had to apply molecular dissection concept in order to identify the pharmacodynamic part and the structural entity which is responsible for side effects. So these were the early changes made, and Small AD in 1929 did some modifications, and they have come out with a few conclusions of structure activity relationships. Then Groove followed in 1949. Benzomorphan and benzomorphan. For the result, Aylab and Showman did their work on methadone series and meperidine series. Fine. So having seen all these things, let us go with the structures. First structure is morphine sulfate. morphine sulfate. So you know the structure of morphine sulfate we have already discussed. This is a pentacyclic ring. This is the phenyl ring. This is another cyclohexyl ring fused to this another cyclohexenyl ring that is fused. And it is a ether link here. Okay. And you have fifth ring that is attached to this carbon and this carbon. This will have methyl group and methyl group. Okay, you have a double bond here. You have a alcoholic group at this position. Another alcoholic group that is phenyl alcoholic group at this position. So by this time you might have got hold of the structure. Okay, so this is a salt of sulfate. So SO4. And you know the numbering 1, 2, 3, 4. Check, is it right? Sorry, numbering starts from here. 1, 2, 3, 4, 5. Let me check. This is 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So that is the numbering. Remember the numbering. That is. And let us compare the structure of codeine, which is also looking similar to that of morph. Codeine. It is also a pentacyclic ring. So draw morphine as such. Draw the structure of morphine and observe the change. You have double bond here, ether link here, and a fifth cycle like this. Nitrogen is connected, this carbon is connected, and you have CH3 here, like in that of morphine. You have a OH group here, like that of morphine, and the final change is you have OCH3 instead of OH. The hydrogen is replaced with methyl group OCH3. That is the only difference between morphine and codeine. Okay, so is it visible on the board? Codeine structure. Someone please confirm.
Yes, sir.
Fine. So this is the difference between morphine and codeine. Only difference is that the phenolic alcoholic group is having the methyl substituent attached to it. Otherwise, it is very much similar to morphine. Now, next chemical structure is meperidine hydrochloride, which is coming under 4-phenyl piperidine analogs. So 4-phenyl piperidine analogs. The first structure is meperidine hydrochloride. Meperidine HCl. Let me write it in short form. So how it looks like. So you have phenyl ring retained and the fifth ring. To this nitrogen, you have methyl group, and here you have a substance that is COOC2H5. So this is the structure of meperidine. So what is it? If you observe, let us compare it with that of morphine. Okay, morphine is there now. So this is the structure of morphine, right? So from morphine, what we are removing? We are removing this ether link. Okay, we are removing this cycle, and we are removing this one also, and we retained this cycle. Got it? And you have a substituent here, COOC2H5. This is how you need to remember. Okay. This is meperidine series. Fine. So let us see the next chemical structure, that is aniline. Aniline hydrochloride. Hydrochloride salt means put dot and put HCl. That's it. Okay. So aniline will have aniline. What is aniline? A phenyl group. A phenyl group having NH2 directly attached to it. Okay. That is aniline. With the help of ethyl link, it is attached to piperidine. That is the reason the name is aniline. Piperidine ring will have a phenyl ring C6H5. I'm abbreviating it. It is a phenyl ring, and COOC2H5. I have to write it continuously as I don't have space. I have written C2H5 beneath. COOC2H5. Otherwise, I'll extend it. Extend it and write. Okay, COOC2H5. So this is the structure of aniline, where you have aniline and you have pyridine or piperidine, because it doesn't have double bonds. This is piperidine. This is aniline. So aniline piperidine. So aniline. So this is the structure of aniline, and that is the structure of meperidine. Okay. So please do compare it with its name and its analog. Next compound is diphenoxalate hydrochloride. Diphenoxalate hydrochloride is the salt. Diphenoxalate. Diphenoxalate, salt of hydrochloride. So how it looks like? Observe. Okay. We have a phenyl substituent here and COOC2H5. To this carbon, this is further attached to through the ethyl link another carbon that is having a phenyl group, another phenyl group, and you have a cyano group. So this makes HCl salt of diphenoxylate. Two phenyl rings. Okay. Likewise, you remember diphenoxylate comes from this moiety. Okay, but you better remember this moiety and compare these two substances from your earlier structures as the one phenyl ring and one ethyl ester group is a common substance in the last two structures also. Okay, so better remember there are two phenyl rings to the carbon attached which is having also a cyano group, and through the ethyl link make it as one moiety and link it to this moiety with the help of ethyl group. Okay, this is structure of diphenoxylate hydrochloride. Then we move on to the structure of loperamide. So this is also similar to that of diphenoxylate, but the changes are as follows. Okay, again phenyl ring which is having a chlorine at its para position, and here instead of COOC2H5 we have OH. We are comparing with that of diphenoxylate. Now it is through the ethyl link, it is linked to one carbon that is having two phenyl groups like as that of diphenoxylate, and here you have C double bond O N CH3 and CH. So this is CONH, both hydrogens of NH2 replaced by methyl. So this is an amide. Okay, if you observe here, you have the same ring that is piperidine here, loperamide, amide, indicating this functional group, and which is very much similar to diphenoxylate hydrochloride. Diphenoxylate structures. Only little difference is there between loperamide and diphenoxylate. Is it clear? Now let us move on to the structure of pentanyl citrate. Pentanyl citrate. So I'll show you the salt of citrate. Okay. You please observe the changes here. Here you have and nitrogen. First, I'll write the substituent. Okay. CH3, CH2, C double bond O, which is connected to a nitrogen, which is having a phenyl substituent and having a pyridine, on the other hand, this nitrogen further extended with ethylene to, okay. So very little modifications somewhat from loperamide and diphenoxalate structures, it is somewhat modified. So how a citrate salt, it is a salt of citrate. So I'll show you the salt of citrate. It is a 3 carbon containing CH2, CH2, and all the 3 carbons are hydroxyl groups. So this is how the citrate salt. Okay. So this is the structure of pentanyl citrate, and let us see the synthesis of pentanyl citrate. Being familiar from the final structure, let us see the starting material for the synthesis of pentanyl citrate, that is propionyl chloride, and see what it is. CH3CH2, C double bond OCl. This is propionyl chloride. This is propionyl chloride, and you remember the basic ring, that is, this is aniline, right? To the aniline, a pyrimidine is fused, not fused, linked. Okay, this can be called as anilino-pyrimidine. Then both are condensed. A condensation reaction takes place. Condensation. What happens? A molecule of hydrochloride will be leaving. So both will get condensed. CH3, CH2, okay, C double bond O, N. This is a phenyl group. This is a pyrimid. Simple condensation. To this, what we'll do, we'll add phenethyl chloride. Phenethyl chloride. Okay, we'll add phenethyl chloride and condense it so that we'll get our pentane. So condensation, a molecule of hydrochloride leaves off, and it will get condensed to our first intermediate and will give us pentanyl citrate. So write the final structure. CH3CH2, C double bond O, N is having a phenyl ring and a pyrimidine ring, to which you have CH2, CH2, that is ethyl link to the phenyl group. So what we did, we have broken here and we have broken here. In first step, we have taken propionyl chloride for this part and anilino pyrimidine. We have condensed them. We got intermediate one. Okay. To this we have added this part and condensed. We got it. So this is very simple condensation reaction involved in the synthesis of pentanyl citrate. Pentanyl. This is just a fentanyl and fentanyl is citrate. You know the structure of citrate from the earlier slide, right? And if you see the next category of drugs, which is phenyl propylamine analogs. Phenyl propylamine analogs. Propylamine analogs. So the first example is methadone hydrochloride. Do we need to learn the synthesis for methadone hydrochloride? Someone please check and let me know. Check the syllabus and let me know if we need to learn the synthesis of methadone hydrochloride. Methadone. Okay, this is methadone. HCl hydrochloride is HCl. So, what is methadone hydrochloride? Let me show you the structure of methadone hydrochloride. CH3, CH2, okay, C double bond O, CH3, CH2, C double bond O, a central carbon which is having two phenyl rings on either side, above and below, and you have an ethyl link and amino group of which two hydrogens are replaced with two methyl groups, and you have one methyl group at this carbon. So this makes it a methadone. This is the structure of methadone. And if you see the structure of its sibling, that is propaxifene hydrochloride, let us compare the structure of propaxifene with that of methadone. Propaxifene. So salt of hydrochloride means just put dot and put HCl. That's it. Okay. So you have a phenyl ring here. Okay. CH2. Now comes the central carbon. Now comes the central carbon, which is having OC double bond O, CH2, CH3. Otherwise can be written as, without getting confused, in linearly O C, sorry, OCO C2 H5. Central carbon, one of the substituent is this, the other one is the phenyl ring, and you have the same substituent, this one, as it is. So what it is? CH, CH2, N, CH3, C See, the methyl group is on this carbon, whereas in methadone, the methyl group was in this penultimate carbon. Okay, so this is the comparison of propaxifene with that of methadone. Okay, so the how the central carbon is attached to what all are the groups makes the contrast between methadone and the propaxifene. And let me show you the synthesis of methadone hydrochloride, and we shall check whether it is part of syllabus or not. Okay, so let us see the synthesis of methadone. Synthesis of methadone. So first we'll take diphenyl acetonite. The starting material is diphenyl acetonite. This is the structure of diphenyl acetonite, right, which is condensed to 1-dimethylamino 2-chloropropane. I will show you. Chloro. So can you guess which part of the molecule it is making? The propionyl side chain at the end. So this is 1-dimethylamino 2-chloropropane. 1-dimethylamino 2-chloropropane. 2-chloropropane. So by condensing and we add sodamide, NaNH2. Condensation a molecule of viscose, we'll get this one. Is that write this? Let me write this here. Okay, let me continue from here. Okay, so diphenyl. Okay, here I'm putting acetonitrile, right? Nitrile group, and we are condensing it to the propyl intermediate. So we get this. Now it undergoes racemization. What is isomerization? Isomerization means the structural and positional changes will happen. What changes it will take? This CH3 will be moving to this CH2. Okay, that carbon from one carbon to the other carbon. This is isomerization. Isomerization gives you the structure where the methyl group is shifted from one carbon to its adjacent carbon. CH2, CH, CH3N, CH3 and another source. So you will get this after isomerization. To this we'll add Grignard reagent to get our methadone. So here the Grignard reagent used is Okay, curved arrows are not used for the space purpose. I'm using. We'll use a base that is sodium hydroxide. Why? I will write this right one only. Okay. So the Grignard we have used here is ethyl magnesium bromide, C2H5 Mg. This is the Grignard reagent we are using, and we got methadone as our final molecule. So how it looks like? Writing it below. So I write here. And this group is C double bond O, CH2, CH3, derived from the Grignard. This functional group derived from the Grignard reagent. And this, as usual, which we saw in the earlier intermediate. Are you following? So this is methadone. Excuse me. So this is the synthesis of methadone. We have condensed diphenyl acetonitrile with acetonitrile with 1 dimethylamino 2 chloropropane to get one intermediate that gets undergoing isomerization, where the methyl groups shifts from one carbon to each adjacent carbon. Then we use Grignard reagent with the help of base to get the methadone. So this is about the synthesis of methadone. Right? So having seen the structure of propaxifene also, let us move on to the next category, that is Morphon Analogs. We have one example, that is pentazose. We have one example for Morphon, that is pentazocine. We have another example for Morphinon, that is levorphenol. One is Morphon analog. Morphon analog. The example is pentazocine. So let us see the structure of pentazocine. So here you have a ring, that is azine. Azine is 7-membered ring having nitrogen as heteroatom, right? So carefully observe it. Here you have nitrogen. So this is 8-membered ring actually. Okay. 1, 2, 3, 4, 5, 6, 7, 8. 8-membered. Okay. Which is fused with the phenyl ring, and it has one more bridging. Observe it, to this carbon and this. And here you have one methyl group. And here you have one methyl. Okay, and this nitrogen is having a substrate that is C double bond C, having two methyl. So 1, 2, 3, 4, 5. Penta. 5 carbons in the substance, so penta. Azosin, remember this complex structure is present and you need to practice this structure and remember likewise the substance with the name pentazosin. And if you see the structure of levorphenol tartarate, which is a morphinon analog, you write that also here on the morphinon analog. The example levorphenol. Okay. So still you remember the morphine structure, right? So this is very simple. If you remember the morphine structure, write down the morphine. This is the structure of morphine, right? Now you remove the alcoholic hydroxyl group and you remove the double bond, okay, and you remove the ether link. So if you remember the structure activity relationships after dissecting the ether link, you will get morphinon analogs. So levorphenol is one of the examples for morphinon analogs. This is the structure of levorphenol. Okay, so you have this is a phenyl ring, this is alcohol, this is a phenol. So this is the structure of levorphenol. How would it is a salt of tartarate, right? Levorphenol tartarate. We saw the structure of citrate earlier. Now let us see how tartarate looks like. Okay, it is a salt of tartarate, which is looking like this. Okay, do you remember anything from biochemistry? This is tartarate, and it has two molecules of water also in its molecular formula. So, am I clear? So, this is all about what morphine and its analogs, narcotic analysis. Let us see their uses. So let us start from levorphenol tartrate. It is a potent analgesic having actions and structure similar to morphine. Okay, so it is analgesic. Okay, effectively for the management of both moderate and severe pain. So pain is the use. Okay, using against the pain to relieve the pain. If you see the use of pentazocine, is a synthetic analgesic agent used to control moderate to acute pain. Again, pain, but you need to remember that it is a synthetic agent. And if you see propaxipine, you see propaxipine, It is used to control mild to moderate pain and used along with other analgesics having anti-inflammatory and antipyretic properties like paracetamol and aspirin. So it is given along with aspirin and paracetamol. Control moderate pain. Okay. So that is the use of propaxone. If you see, methadone is also one of the analgesic, and fentanyl citrate. Pentanyl citrate also potent narcotic analgesic employed as analgesic for arrest of pain. And loperamide, it is a safe and effective opioid derived anti-diarrheal agent. This is most commonly available anti-diarrheal agent over the counter. So this is somewhat different, right? Other than pain, anti-diarrheal agent. Loperamide. ఎప్పుడైనా మోషన్స్ అయితే పోయి loperamide అంటాం మెడికల్ షాప్. Okay. So you need to remember its use very much different from others. Okay. And diphenoxalate is analgesic. Then comes meperidine and analerdin, and both are synthetic analgesics and having pain arresting properties, and morphine and codeine also same. So these are the uses of narcotic analgesics. And we have narcotic antagonists to along with narcotic analgesics. What are they? What are they? Narcotic antagonists, you have three compounds. One is Naloxone Hydrochloride, which is pure antagonist, and levolorphan, which is agonistic in nature, and naloxone, which is levolorphan type. So narcotic antagonist. Narcotic antagonists. One is Naloxone Hydrochloride. Naloxone Hydrochloride is the salt. Okay, let us see how it looks like. Okay, if you remember structure activity relationship, most of the times, if you remember this point, if you have tertiary nitrogen, the substituent attached to tertiary nitrogen, if it is allyl, that will act as antagonist. If you remember that point is very, very important. And if you observe all these three structures have allyl group attached to nitrogen, the tertiary nitrogen. I will show you. You know the structure of morphine. If you know the structure of morphine, it is very easy to remember. So draw the structure of morphine. Pentacyclic ring. You must be acquainted with drawing the structure of morphine with ease, very easily. So phenanthrene type, so draw phenanthrene ring first. But only one phenyl ring, you have double bond in this ring. Okay, you have ether link between two rings, and you have one OH here and another OH here, third and sixth positions. Okay, and the fifth ring is linking the tertiary nitrogen and like this. Usually we saw methyl group here in the morphine, but to act as an antagonist, we are simply modifying morphine, just replacing the methyl group with allyl group. What is allyl group? I'll show you. What is allyl group? CH2, CH, double bond, CH2. This is the allyl group. And if it is a salt of HCl, put dot and HCl. That's it. So this is the structure of naloxone. Okay, so you have to remember this point from structure activity relationships and observe. That is the reason I have discussed structure activity relationships in the beginning of discussing the chemical structures. Okay, you need to observe the differences in order to remember the SAR, structure activity relationships. Fine, let us see the other two antagonists, that is level orphan tartrate. Level orphan tartrate. So if you remember, we have discussed it. A similar drug like levorphenol tartrate, right? Levorphenol tartrate is a narcotic agonist, while levorphen is antagonist. The similarity of names should not lead to confusion. Okay, both are tartrate salts. Okay, so what is the structure of levorphen tartrate? From levorphenol, if you compare the structure, instead of methyl group, you have allyl group. Otherwise, the structure of levorphenol and levorphen are same. Only at the position of substituent attached to nitrogen, it is allyl in case of levorphen and it is methyl in case of levorphenol. Just changing the functional group, making the drug antagonist from agonist. Okay, so that is what is required from a person having medicinal chemistry background to change what groups to make the biological actions modified. Okay, so let us see the level orphan tartrate. So let me write somewhat beneath so that we can accommodate the fifth ring. So draw the pentacyclic ring, first phenanthrin. Okay, and here, here this is not a morphine, but we have molecular dissection and we have removed this ether. Okay, fine. This is the structure and put allyl group to nitrogen and you have phenolic alcohol. What is allyl group? CH2, CH, double bond, CH2. This is the structure of level orphan. Level orphan and the tartarate structure, you know, right? COOH, COH and H, and other H and OH, again or another carbon. This is the salt of tartar. So, pharmacologically and chemically, it is very much similar to morph. And the last drug, that is naloxone hydrochloride. Naloxone, naloxone, salt of HCl. So hydro. So again, draw the structure of morphine. Here you have ether pitch. Pentacyclic. Draw the phenanthrin first. phenanthrene draw. Okay, here it is double bond O, put ether linkage. Here one hydroxyl group. Okay, the fifth cycle. And sorry, here you have hydroxyl. Okay, and here you have allyl group. Okay, so what is the difference? You don't have double bond here. Here hydroxyl group is into ketone group. Okay, here to this carbon you have attachment of hydroxyl group and allyl functional group at tertiary nitrogen, the common feature in antagonists. So this is the structure of naloxone hydrochloride. And if you see the use, it is a specific narcotic antagonist that is possessing no morphine-like properties. Okay, this is very specific narcotic antagonist, and it will reverse the narcotic analgesic effect. If overdose of narcotic analgesic is taken, we can give naloxone hydrochloride. Okay, HCl, put HCl next. Specific narcotic antagonist. Narcotic antagonist. And if you see level of one, which is somewhat related to morphine, and if you see nalorphine, it is also employed effectively to reverse the narcotic induced respiratory depression. To reverse narcotic induced respiratory depression. Respiratory depression. So these are the uses of narcotic antagonists. Okay. Are you able to follow? Are you following? Okay, so the next topic is anti-inflammatory agents. So where we cover non-steroidal aromat anti-inflammatory drugs. Okay, so lastly, we'll see the classification and we'll wind it up. So the classification of anti-inflammatory agents include anti-inflammatory. That means these are synthetic drugs. Okay, inspired from narcotic analgesics, but these are different category of drugs which doesn't possess steroidal ring in their chemical structure. Okay. So it does have 9 types of chemical moieties. First one is salicylic acid derivatives. Salicylic acid derivatives. So the examples are very common over-the-counter drugs you might have prepared in your laboratory in your first year also. It's the pandemic alone. Sodium salicylate and aspirin. These are the two examples for salicylic acid derivatives. The second one is N-aryl anthralinic acid derivatives. N-aryl anthralinic acid derivatives. So the examples are mefenamic acid and meclofenamate. Mefenamic acid, mefenamic, this is A. Okay, mefenamic acid and meclofenamate. Meclofenamate. And the third category includes heteroaryl acetic acid analogs. Heteroaryl acetic acid input this, that means acid, and analogs. Examples: indomethacin, indomethacin, he may be there, may not be there. Tolmetin, zomepriac, zomepriac. These are the examples for heteroaryl acetic acid. If you see fourth category, that is aryl acetic acid analogs. Aryl acetic acid analogs. So examples include sulindac and diclofenac. Sulindac and diclofenac. So these days you are hearing the name of diclofenac very much. Okay, why? If you got you vaccinated, the guys who are vaccinating you are telling that you should not use any painkillers, particularly diclofenac, because there are cases where after taking vaccinations, it is very common to feel body pains, feverish, and etc. Okay, so in such conditions, people who took diclofenac or aceclofenac painkillers were experiencing complex reactions in their system and biological system, and sometimes it is leading to death also. So that is the reason they tell you you take only paracetamol. Other than that, you should not take any drug. Okay, particularly diclofenac. So you must be appreciating this fact that you are learning about these drugs. Okay, and whatever the drugs we have learned till now will come into the picture if you observe carefully the pharma updates. Okay, so this is it. This is an example belonging to the category of aryl acetic acid analogs. Moving forward, the fifth category, that is pyrolysin derivative. Pyrolysin derivative. So the example is ketorolac. Ketorolac. LAC. Ketorolac. The sixth category is aryl propionic acid derivative. Aryl propionic acid derivative. So the example is ibuprofen. You might have heard its name and you might have used it over the counter. Brufen antaram. Ibuprofen and naproxen. Aryl propionic acid derivatives. Then seventh category is oxycams. Seventh category is oxycams. Example is piroxicam. This is one of the drug everyone will have in your memory. Why? Means in the childhood, when you get a fever, severe fever, you might have been taken to the doctor, to some clinic or hospital, wherever it is. You might have been injected on your buttocks, right? The back. Excuse me. And you might have felt the pain of injection. Okay. So that is piroxicam. Remember that green color vial. Okay. Having some label and doctors injecting you with their sharp needle and you scolding the doctor for n number of days till that pain goes on, and that made you to fear the injections. So that is piroxicam. Okay. So know all these things and relate your memories with the drugs you are learning. Then it will be enjoyable to learn the chemistry of the drugs we are using. Okay, tomorrow if you can appreciate their chemical structures and you can understand and contribute to the society, that is a big expectations from you, from your parents and the society. Okay. Then eighth category, that is aniline and para-aminophenol analogs. Para-aminophenol analogs. So the example is phenacetin. This is phenacetin, and the next drug is your very favorite drug, that is your nurse told to take after vaccination, that is paracetamol. So do you feel now as a pharmacist, after hearing the name of paracetamol, yes, this is the drug I am hearing since the ages from my grandmother, grandfather, their grandfather, until the children, kids, kin and kith using in families, villages, whole countries, all old, and even the nurse who gave the vaccination asked me to take paracetamol, and now I am learning about paracetamol, so I must be a pharmacist, right? So this is somewhat what we say SS Rajamouli's goosebumps scene. Okay, so and you should now recollect from your unit 1 till now so that you can appreciate yourself as a pharmacist. Okay, so if paracetamol along with its sibling phenastine comes under aniline and para-aminophenol analogs. So what is the other name? Acetaminophen is the name of paracetamol. Acetaminophen, and it causes liver toxicity if taken in higher doses, and if you taken it for more than 4 grams per day, it will cause liver toxicity. Okay, don't think that it is very safe drug everyone using, so I can drink it like anything by mixing in our 1 liter 2 liter water bottles bringing to the college. Okay, we should not take more than 4 grams per day. And the last category, and our happy moments of ending the class coming nearer by knowing this last category, that is pyrazolidine diones. Pyrazolidine diones. Examples are antipyrine, and phenylbutazone. Phenylbutazone. You might have seen this in your laboratory if you have performed any assays. So this is the classification of anti-inflammatory agents. Okay, and with this we conclude our today's session, and we'll discuss the remaining in the next session.